Hello again. In this video, we're going to go over the derivatives of the inverse trig functions. So the derivative of arc sine of x is 1 over the square root of 1 minus x squared. Now notice the derivative of arc cosine of x is very similar. It has a minus sign in front. And this is true for all x values trapped between -1 and 1. Now the derivative of arctangent is 1 over 1 plus x squared. You can see the derivative of arc cotangent is very similar except has a minus sign in front. In this case, it's true for all x values. The derivative of arc secant is 1 over the absolute value of x times the square root of x squared minus 1. And again, the derivative of arc cosecant is very similar, except it has a minus sign in front. This is true for all x values where the absolute value of x is greater than 1. Okay, so I just want to do an example where we use some of this. So let's say you wanted to find the derivative of the natural log of the arctangent of 3x squared. Now clearly you're going to have to use the chain rule here because this is a composition that occurs twice between 3 different functions. So the first time we use the chain rule, the inner function is going to be this arctangent. So let's let u be arctangent of 3x squared. And then that means the outer function will be natural log of u. Okay, and then let's find dy du and then multiply it by du dx, and that'll give us dy dx. Okay, and I guess this is being called y. Okay, and we're finding dy dx, just to be clear. Okay, so let's find the derivative of y with respect to u. Of course, that's just 1 over u. And then let's go ahead and replace the u. It's equal to arctangent of 3x squared. Okay, so that's the outer derivative. And then the inner derivative, we're just going to take the derivative of this with respect to x. Of course, to do that, we're going to have to use the chain rule again, because this is actually a composition of functions unto itself. Okay, so let's find du dx using the chain rule. So we're going to say du dv times dv dx. Okay, in this case, v is going to be the inner function, and u is going to be the outer function. Okay, so in this case, the inner function is 3x squared. We're going to call that v. And then the outer function will be inverse tangent of v. Okay, now let's find du dv, which will be the derivative of this function, which of course, by theorem 320, is simply 1 over 1 plus v squared. And then let's go ahead and replace the v. V is actually 3x squared, so it's going to be 3x squared squared. Okay, now let's find dv dx. And by the power rule, that's just 6x. Okay, and so du dx, which is what we're trying to find over here, by the chain rule, will be the outer derivative. I'm going to go ahead and write that as 9x to the 4th power times the inner derivative, which is just 6x. Okay, and so that is du dx. So again, to find this du dx, right, the inner derivative for the first time we used the chain rule, we had to use the chain rule to find du dx a second time, and that's what we're doing over here. Okay, but now that we have du dx, we now have the inner derivative for the first time that we used the chain rule. Then we have to multiply that by the outer derivative, and that'll give us the derivative of dy dx, or dy dx, which is the derivative of this function. Okay, so let's just multiply these two together. Okay, and so that's the derivative. I guess you could simplify it a little bit more just by putting the 6x on top. Okay, so the derivative of this, natural log of arctangent of 3x squared, is equal to this. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.